Hello viewers, you're welcome to my YouTube channel. This is Kemi's here, and today we'll be doing the qualitative analysis of an inorganic salt and a mixed solution. Alright, so the inorganic salt is zinc 2 chloride, and also we'll be doing qualitative analysis on powdered mixed solution. Alright, so from the requirement given there, CN is our zinc 2 chloride, YDN is our mixed solution. Okay, so we'll be asked to analyze or test for the presence of zinc 2 ion in this zinc 2 ion, and I don't think we'll be asked to look for chlorine to test for the presence of chlorine, since from the requirement there the reagent to test for chlorine is not there. Alright, you want to test for chlorine, you need silver nitrate, and you need lead 2 nitrate. So these two reagents are needed to test for the presence of chlorine. So from the requirement there is not provided, so you might not be testing for it. Alright, so let's go back to the practical demonstration. Here we have these are the questions will look like. So CN is an inorganic salt and DN is an unknown solution. Carry out the following exercises on CN and DN. Record your observation and identify any gases involved. State the conclusion you draw from each test. Alright, so you start first by putting all of C in a test tube and add about 5 ml of distilled water. Stir and test with litmus paper. Divide the solution into two portions. To the first portion, add sodium hydroxide in drops and then in excess. To the second portion, add ammonia in drops and then in excess. Then you put DN in a test tube. Then you add about 1 ml of sodium hydroxide and 5 drops of 1% copper sulfate solution. Alright, depending on how you prepare your copper sulfate solution, 1% just means 1 grams of copper sulfate in 100 ml of water. Alright, that's 1% copper sulfate solution. So here is the table here. Alright, so the test, we have CN, which is your zinc 2 chloride plus water. Now CN dissolve in water to give a colorless solution. That means CN is a soluble salt. Okay, zinc 2 chloride is very soluble in water, and plus litmus paper, it turns blue litmus paper to red, and CN is slightly acidic. Take note, it is formed from the neutralization reaction between a strong acid and a weak base, which is HCl. So the salts still have some acidic properties, so it will definitely turn blue litmus paper red. So, alright, we add CN into the test tube. Then we add little quantity of water. Then you ensure it dissolves properly in it. As you can see, this is done to ensure it dissolves properly in it. Then we divide into two equal solutions. So we'll go further to test CN with litmus paper. So this blue litmus paper, you observe it turns blue litmus paper to red. So CN is acidic salt. CN plus sodium hydroxide in drops, it gives a white precipitate. Alright, the white precipitate is due to the formation of zinc hydroxide. Alright, and this tells you the presence of zinc 2 ion or aluminium. Alright, these are the two ions that can give you a white gelatinous precipitate. Then in excess, the precipitate will dissolve to give you zincate ion, which is this, to give you zincate ion. This is soluble ion. Alright, so this also tells you that zinc 2 ion or aluminium is present. Alright, so the first portion, we add sodium hydroxide in drop. We have a white gelatinous precipitate formed, as you can see, and in excess the precipitate dissolved to give a clear and a colorless solution, which you can see. Then CN plus ammonia in drops. Plus ammonia in drops, it also gives you zinc hydroxide, the white precipitate of zinc hydroxide, which also tells you the presence of zinc ion and aluminum ion. Then in excess, this is where you differentiate between zinc and aluminum. In excess, aluminum do not dissolve in excess ammonia. All right, it's only zinc that dissolves in excess ammonia. So this confirms the presence of zinc ion. All right, here we go. And when you add ammonia in drops, it gives you a white gelatinous precipitate. As you can see, in excess, the precipitate dissolves to give a clear and a colorless solution. All right, we'll go back to the D of it. Now, in this other aspect of it, you want to test for the presence of protein, and this kind of qualitative analysis is called burette analysis. All right, it's a mixture of burette reagent is a mixture of sodium hydroxide and copper 2 sulfate. It is used to test for the presence of protein in a compound or solution. All right, so now we have Dn plus 1 ml of sodium hydroxide. Now when you add sodium hydroxide to Dn, the solution might become more opaque or cloudy due to the denaturation and precipitation of the milk protein, but there will be no significant change in color. All right, then on addition of copper sulfate, the copper reacts with the precipitated protein and the solution turns purple. All right, so it turns purple. Some articles you see violet, but from observation it turns purple. All right, the purple color indicates the presence of protein, and this type of analysis is called burette analysis. All right, so these are powdered milk. So we'll make a solution of it by adding little quantity of water, and then you shake vigorously to ensure it dissolves properly, homogeneously. And then we'll add caustic soda, about 1 ml. You observe the solution becomes a bit cloudy and opaque. And then we'll go further to add our copper sulfate in drops. And you observe the formation of a purple color, which tells you the presence of a protein. As you can clearly see, you can see the formation of a purple color. This tells you that protein is present in this solution. So this is called the burette test for protein. Thanks for watching. Please do comment, like, and share this video, and also subscribe.